Good afternoon, everybody. Welcome you all on this wet Wednesday afternoon in Auckland. I hope you're having a great week despite the inclement weather. So thank you all for joining for this third webinar for this year in relation to water quality. I'm your host, Kalyan, working as a principal water quality scientist here at DHI Water in New Zealand. The topic for today's webinar is wetlands for water sensitive cities. If anyone has any problem trying to hear me or see my slides, please just let me know. You can just post it on the chat message box or on the Q&A thing. I'll try to fix any problems. I was having a problem with Zoom yesterday, so that's why I'm wondering. So let me know. If not, we'll just kickstart this webinar. We have short time. And this time I was told to keep it short, finish it within half an hour so that you all can enjoy your lunch and go back to your work. Just to recap, this is the third of the webinar series. The first one started in April, talking about heavy metals in urban waterways. The second one was about modeling water quality in rivers. So these are a series of educational webinars which we are doing from DHI. Just to give you an overview of the different things which we can carry out in terms of water quality, be it management, modeling, and different aspects of contamination, pollution. So nothing specific about, I'm not trying to sell any mic software here for you, but in general, I'm just trying to create awareness around water quality here in New Zealand and bringing in case studies, examples from New Zealand as well as from abroad as well. In case you have missed any of these previous webinars, we do have a YouTube channel. Everything is uploaded in the YouTube channel. Let me know if you're not able to find it on YouTube. If you search for this DHI New Zealand webinar series and say you're not able to find it, just drop me an email. You have my email. I'll share with you my email at the end of this webinar presentation as well. Otherwise, it's just cmk@dhigroup.com. So thank you all once again for joining me today afternoon for this particular topic on wetlands for water sensitive cities. As usual, before I start, I like to acknowledge the support given by my boss as well as my colleagues in making this presentation happen on time for you all. So why are we worried about cities? I'm a big fan of cities, not just because of the great things cities offer, but also in terms of, for me, especially in water quality context, cities are great because we either have too much water or not enough water in cities, and this always causes pollution. And as you know, dilution is not the solution to pollution, but people always say, oh, there's too much water, that's great. We can always dilute all the pollutants entering in. But it's all about mass balance. I'm a great fan of mass balance. And all that mass has to go out somewhere, has to reach somewhere, has to settle down somewhere. And that's where all the pollution. So if you're doing dilution, you're just transferring the problem from one area to another area. So I really like this graph when I first saw it in a presentation given by Prof. David Maidment from UT Austin. And I thought I could start this webinar with this particular slide saying, the cities face lots of problems, especially if you want to divide into 4 categories: too much water, not enough water, water pollution, and ecological integrity with the water. There was even a study done, and this is from USA, where they actually said that cities especially, 10 trillion gallons of untreated stormwater. So that's in liters, that's almost like 37 or 38 trillion liters of water, which is making into our receiving waters. So, and this is all untreated. So all of this enters into our receiving water. So there is a lot of pollution and contamination in our receiving waters, and we really want to do something about it. And that's what the whole topic is all about. What can be done to mitigate or to reduce the amount of contamination entering our receiving waters? So when we talk about water sensitive cities, the term or the origin, we should go back to this particular framework. Many of you might be familiar with it. For me, this has been very helpful when I started out working in this aspect of water resource management. Earlier, I was just looking into water quality and trying to do data analysis and modeling. But when I started looking further into where does water quality fit in the water resource management framework? How does it fit into managing city waters, and how does it fit into managing city waters along with the green infrastructure assets? So this was very helpful. And over the past 10 years, whenever I have given presentations to ministries or even ministers, having this kind of framework really puts them in, gives a context to them to help them identify where their city is or where their town is. And in a few presentations I attended during the conferences or the past 2 years here in New Zealand, I've observed that MFE keeps on hinting that we are somewhere between, most of the cities in New Zealand are somewhere between drained city and waterway city. But what exactly are these 6 different city stages we are talking about? Just to give a context to those who are not familiar with this particular concept of urban water management evolution framework. So we all start with a water supply city, in the sense from villages, when we moved into cities, we need to supply water to all the residents living in the cities. I mean, that's the first focus. We have to supply water. But then the next question arises is, yes, we are drinking all the water, but we have all this effluent coming out. What do we do with it? So we can't just allow all the black water just to enter into our roads and drains and all that stuff next to our houses. We got to evolve it. So we got to think about the next stage. And that's where the cities, and I have to tell you, most of the cities in Asia Pacific, which I have encountered, they're still in this stage. They don't have proper sewage facilities. And that's where they're concentrating all their efforts on the sewage city, because this is their big challenge, which they want to encounter, which they want to address before they move on to the next aspect of it. And that's where the next aspect comes in. We're saying, okay, we have addressed water supply, we have addressed the sewerage situation. What's next? And what's next is what happens when there is storm water, when there is storm events, and then there's flooding on the roads, and how do you take care of the flooding on the roads? And that's where the evolution takes place in the city councils and authorities. They start talking about, okay, let's try to address this flooding. And for that, earlier, historically, when you had a lot of land, you could build these big canals, if you can say that, or big channels, open channels, so that they can be used for draining all the excess water. And mind you, in Singapore, not too long ago, we had this formula that, whatever rainfall falls on the ground, it has to be discharged away from the catchments, all within 3 to 6 hours, nothing more than that. So that used to be the mobilizing factor for all these building. Let's build as many open channels as possible so that we can take away all the stormwater away from the catchment, so that there is no property damage and stuff. But then you start to realize that you don't have storm events all the time. And the next thing is, when you do have storm events, these channels, some of them might not even be sufficient. So most of the time they're either like this, just draining a little bit of water away from the catchment into the receiving waters, or in extreme cases, they might be like this. And with all this climate change happening, the number of these extreme events are increasing on year-to-year basis. So how do you account for that? And that's where the evolution takes place to the next step, which is the waterway city. And lots of cities have been focusing, have been putting their efforts into this area. They're trying to transform their water drainage city framework or their approach into a waterway city approach, and hopefully to the next stages, which is the water cycle and the water sensitive city approach. So I know that in Singapore, more than $30 million or close to $40 million was spent on trying to transfer some of these waterways, some of these canals under the water drainage concept directly into the waterways concept, where they can work as naturalized drains or naturalized rivers to allow the overflow and to allow the water to get away from the catchment into the receiving waters, to allow infiltrations, to make it as much natural water cycle as possible, rather than from a concrete impervious point of view. A few examples to share with, and this can happen. So this evolution happens in every city. Since I have some experience working in Asia Pacific, so I'm sharing with you some examples where in 1960s you had this Grand Canal. It was in the middle of the city, and pretty much working like a sewerage canal. And this was in 1960s when the city wasn't much developed. And that's where the whole evolution trying to show how it can happen. So from a sewerage city, when the government authorities decided, let's move on to the next step and let's clean up this canal into something which could be useful for stormwater propagation or pathway. And that's where it became a drainage city. And now this city is now, this is in 1980s, late 1980s or early 1990s. And now they want to move on to the next step. That's why they are focusing their infrastructure efforts on evolving it from a drainage city into a waterway city. And there you go, you can see the transformation happening. So then the question next is, how do we go from this waterway city to the next stages, water cycle and water sensitive cities? Something like this, where you have more amenities, you have more ecosystem services, where aquatic ecosystem plays with human health, where humans play a role in making sure that the catchment is free from all kinds of pollution. We recycle a lot. We don't allow any kind of pollutants to enter up into our waterways, and we enhance the infiltration, natural infiltration happening. So basically reducing the effective impervious area in the catchment. So all these different aspects come into play, and so that we can evolve to the next stage, which is the water sensitive city. So if you go to the CRC website in Australia for water sensitive cities, they give a very nice definition or description of what a water sensitive city is. So it's basically a city which can act as a water supply catchment. So when you talk about a water supply catchment, you're not just talking about a stormwater catchment, you're talking it as a potential water supply catchment. That means you have to make sure that the water in your catchment is of reasonably good quality. So it could be used for primary recreation purposes, swimming and kayaking and all those kinds of stuff. And it also talks about a water sensitive city which has waterways which provide ecosystem services and a healthy natural environment, in addition to mitigating flood risks, in addition to enhancing the health of waterways and economic prosperity and stuff. So since I come from the water quality background, so I'm going to filter this aspect or these features of water sensitive city from the view of a water quality practitioner. I hope you can forgive me for that. If you're really looking for social, economic, and or even flooding related aspects of water sensitive city, I don't think I'm the person to talk about. But from a water quality perspective, from an ecological perspective, I can more than work with you guys on this. So from a filtration perspective, from a water quality perspective, if you talk about water sensitive city, what kind of principles should be used? And I think this Australian terminology of water sensitive urban design, it's really more like a philosophical framework rather than calling it as an alternative to LID or BMP or green infrastructure. I really like their approach towards design principles for evolving your city from a waterway city into a water sensitive city, where principles involve like protecting your water ecosystems, improving the quality of discharged water into the urban receiving waters, and talking about integrating water amenities to provide you ecosystem services in terms of water quality, in terms of ecology, in terms of improving your ecological values, and also trying to utilize your land spaces for multiple purposes rather than just for aesthetic sense or just for recreational purpose or as a water retention pond, something which can integrate all these different ecosystem services together. So these principles promote that kind of framework, and I think that's really great. I'm sure most of you agree with that as well when you dig deep into it. So as part of this framework of water sensitive urban design principles, all over the world, pretty much lots and lots of different types of examples have cropped up, like can we have permeable pavements or rain gardens or green roofs or planters or barrels or swales and trenches and stuff like that. So Either you can use them independently, or you can use them as a set, as something which works in series, so that you can have multiple interventions for your stormwater, so that they can go through the cleansing process. And I think that's really great if it can happen. And this is an example of a treatment train in London, and something which I was which I am intimately familiar with is this cleansing biotope, also working as a wetland treatment train back in Singapore, where we had a hybrid of bioretention basins and wetlands. And it really helped improve the whole aesthetics of the park and the waterway and the pond surrounding it. And at the end of the day, we had a highly eutrophic, I mean, before the whole process started, we had a highly eutrophic pond with chlorophyll biomass of more than 400 micrograms per liter. And after implementation of all this wetland treatment train approach, cleansing biotope approach, we got concentrations of chlorophyll less than 10 micrograms per liter. Now that's a great achievement over years, considering that we're not going through any kind of membrane filtration or something of the sort. It's just pure using natural way of treating water. So there are multiple benefits for having such kind of wetland treatment train option. So in addition to improved water quality, we can reduce the costly flood events, we can alleviate downstream erosion, improve stream habitat, and even for those who are talking about urbanization and density increase, and that leading to urban heat effect. So hopefully these wetland treatment trains can also work in the aspect of reducing your urban heat island effect as well. And also improving your groundwater recharge, and especially for those cities which suffer from paucity of rainfall, it can even act as rainwater harvesting options, as it retains the water on site. So you do remember whenever I talk about in the previous webinars, when I'm talking about features, I try to bring in some equations into it, because I think it really puts a very good perspective rather than just talking wishy-washy on how great wetlands are to help your city evolve from waterways to water sensitive. It would be nice to put some numbers to it. And as you know, I'm a big fan of mass balance. So I always see it in terms of these mass balance concepts. So say, for example, we take this particular treatment train approach where we divide a treatment train into multiple tanks for just a numerical analysis case. And we assume how much amount of water is flowing through the system, how much amount of concentration is there, background concentration is there based on the area. We can actually calculate and compute what is the concentration coming out. So either you can do it in a steady state basis, or you can do it in a dynamic situation as well. And through simple mass balance, you are able to obtain these equations, which tell you what the flow is, what the concentration is in the previous tank as compared to the next tank, and what is the effluent concentration going to be as compared to the influent concentration and the background concentration. Say you have an example. Say you want to treat 1 million gallons per day of water, which you think is coming out from your catchment, and it is highly polluted. It contains phosphorus at very high levels. It should be less than 1 milligram per liter according to the guideline values, but it has more than one, which is, say for this example, it's 5 milligrams per liter of phosphorus, and you have certain background data in terms of rainfall and evapotranspiration, infiltration, and all that stuff. And you really want to know whether this particular area, which you think could be assigned for a wetland treatment train, 20 hectares area, would it be effective in reducing your phosphorus levels from 5 milligrams, and how much reduction can you observe? So by applying these equations, just simple, you can do it in Excel, or you can do it by hand as well. You get these results. And you can get these results starting with assuming inflow, assuming you have 3 tanks, you divided your 20 hectare area into 3 tanks or 3 different wetland types, and then you can actually see how much reduction you can observe from at each of these tanks, and eventually how much reduction you can observe finally from the wetland. So for this particular example, we could see that you can observe close to 85% of reduction in terms of phosphorus. So that brings down the result of phosphorus. The influent was around 5 milligrams per liter. And by having this wetland treatment train approach, we can bring it down to 0.73 milligrams per liter, which is close to the guideline value, not really down there. But if you really want to bring it further down, then you can play around with it and identify whether you need to change the area. I mean, that's the only thing which we can work about here, or we need to change the water depth in the wetland, you know, or increase the porosity or something of that sort. So all these things are possible. And that's what I wanted to share with you in this webinar, that by having a wetland treatment train approach, we can carry out a simple numerical mass balance approach to, or we can apply, sorry, we can apply mass balance to understand how much reduction contamination you can get in your city, in your catchment. We can also do it in a dynamic sense, and Mike software does allow for that. You can do this application of this water sensitive urban design systems at 2 different levels, be it at a catchment level if you want to assess the required efficiency of your targeted systems, or you can even do it at a detail level, like you want to put in a specific water sensitive system and you want to see you want to do the hydraulic assessment and the water quality assessment of that particular device. So both of them are possible, and they can be done using the Mike software at the dynamics level rather than at steady state. So I think this is where some of the Mike software, which have been developed over years for discrete purposes, they can be integrated together to solve this problem of where should we site the green infrastructure, how effective the green infrastructure would be, and how much improvement can we get, and how much the receiving environment can benefit by having these kinds of green infrastructure in the catchment. I think all those questions can be solved by integrating Mike Shi and Mike Urban software. So this is just a representation of how what a sensitive urban design system could be implemented in the Mike software, because it allows for all these different features like infiltration, percolation, and infiltration to the ground, leakage into the ground, and evapotranspiration. So all these different aspects to be modeled as part of your modeling system, as part of your whichever application you're going for, catchment-based or network-based. Just to give you screenshots of examples of how you can do it. If you're familiar with Mike Urban, you might be familiar with these editors as well, control editor as well as deployment editor. So summarizing, since we are running short of time, it's almost 12:25. Wetlands are a great opportunity for us to evolve from a water-based city into a water-sensitive city. They offer lots of advantages. Either you can use a simple mass balance approach to determine how much reduction you can get in your contaminants, or you can use dynamic approaches, say, for example, using Mike software to run the whole thing. I believe that's it from me. Thank you very much for your patience. I'm glad that all of you stuck around. Oh, that's really great. We have more than 25 participants today, so I'm grateful to all of you. If you want, just drop me an email. We can provide you the link for the YouTube for this webinar, and if you have any questions related to this topic or the previous topics we discussed about, more than happy to answer your question. So that's the end of this webinar today. If you have any quick questions which you'd like to be addressed now, we can take it. If not, just drop me an email. Thank you very much.